So I asked a few questions on sketching quadratics using completed square form in a previous video. What I'm going to do now is I'm going to work through those questions, show you the answers and the steps that would give you the best results. So quick refresher for you. Using completed square form, sketch the following quadratics. So I've got y equals 3x squared minus 6x plus 1. Second one is y equals 2x squared minus 20x plus 80. And the third one is y equals 25 minus 12x minus 2x squared. So I'm going to sketch all three of them using the completed square form rather than going through all the other steps. Now remember, we said completed square form helps us when the graph has no roots. So when our function has no roots at all, that helps us in order to be able to calculate it effectively. Now this one still does have roots, but completed square form does help us to sketch the graph quickly and efficiently as well. And I'm going to demonstrate that to you now. So I've got y equals 3x squared minus 6x plus 1. So we've got to start by putting it into completed square form. We start by focusing on this bit and taking out the coefficient of the x squared as a common factor. So in this case, I want 3x squared minus 2x, close bracket, plus 1. Remember, we want it in the form a bracket x plus p squared plus q. That's how we want completed square form to look. And that'll tell us the turning point straight off. So I've got this here. I then focus on this section here to start to put it in that form. So because of that, I would end up with x minus 1 all squared. Remember, we look at half of this. Take away this squared. So take away the negative 1 squared. Remember, that's our correction factor. And then we fill in the gaps around. So we have the 3 at the front and still the plus 1 there at the end. So that's what this looks like so far there. We can then multiply this bracket out and simplify the whole thing. So I get 3 bracket x minus 1 squared. And I get minus negative 1 squared. So that's just minus 1. But it's minus 1 times the 3. So it's then minus 3. And then plus 1 at the end. And I can simplify it down to say y equals 3 bracket x minus 1 all squared, take away 2. So that's me got my graph in completed square form. Now from this, remember I can read off my turning point. If we have it in completed square form here, your turning point is given by negative p comma q. We're able to just read it off from that. So looking at this one, I can simply read off my turning point and say to you that it's 1, because it's negative of this, and it's negative negative, which gives you a positive, comma negative 2. So I know my turning point is somewhere around about there, 1 comma negative 2. What I've then got to do is calculate my y-intercept. And remember, to get our y-intercept, we set x equal to 0. So in this case, I'd get y equals 3 times 0 squared, take away 6 times 0 plus 1. So my y-intercept is y equal to 1. So it's somewhere about there. Now, as I've said, this one still does have roots, but it cuts the y-axis at 1, and it's at 1 here in the x-axis, so that means my first root is somewhere between 1 and 0. So we're not able to factorize this. We'd have to use the quadratic formula to get it and then be able to build it up. So this just makes that a heck of a lot easier to do. What I can then do at this point is fill in the gaps. So I'll be able to fill in this part of the curve going off up that way, come down here, and have this part of my quadratic going off that way. So I'm able to then sketch it and say, fine, so y equals 3x squared minus 6x plus 1. There's my graph there. Let's look at another example. So the second example was this one, y equals 2x squared minus 20x plus 80. Again, focus on this bit to start and then whittle it down. Get rid of the coefficient of x squared as a common factor. We take it out, so it's 2 bracket x squared minus, common factor of 2 there, 10x, then plus the 80 on the end. Then, focus on this section here. Half this number, I get x minus 5 squared, then my correction factor, take away that negative 5 squared again. Then got 2 at the front, and a plus 80 at the end. Multiply out this bracket and start to simplify things. So I get 2 bracket x minus 5 squared. I've then got minus 5 squared gives me 25, but remember it's 2 going into here, so it's 2 times the 25, which means it's minus 50, then plus 80. So that then gives me 2 bracket x minus 5 squared plus 30. From that, I can read my turning point off straight away. My turning point for this one, negative of this, so it's negative negative, so it's plus 5, comma 30. I then find my y-intercept from that. So I know substituting in x equal to 0, what I end up getting is y equals 2 times 0 squared minus 20 times 0 plus 80. So my y-intercept is equal to 80. So I know it's going to cut here, up there at 80. Again, remember, this doesn't have to be exact, it's just a drawing. It's just a sketch. And there's my 5,30. Now this is one of the ones you look at and think, well, that doesn't have any roots. I wouldn't have been able to calculate that and factorise it, so this is definitely a big help to that one. So my curve goes off in this direction here, and it goes up in that direction there, and then I name it. So I know y equals 2x squared minus 20x plus 80, and label your axes as well. So there's my y, there's my x. So I've sketched it. Completed square form lets me do this because I don't need to work out the roots to get my turning point. Ones like this where it has no roots, it's vital to be able to do if we want to sketch it. Last example we had was y equals 25 minus 12x minus 2x squared. Now this is the other way around. Sometimes what helps to factorise it and put it into completed square form is to write it the other way. So I have it as minus 2x squared minus 12x plus 25. Because this one ultimately is going to be in the form y equals q minus a bracket x plus p squared. It's going to be in the other form. So if we factorise it, we can then just write it back to front into this form. So again, we start to look at this and we take out the common factor. So in this case, it's negative 2. So it's negative 2 bracket x squared. Remember, it's negative coming out, so that changes to a plus 6x, then plus the 25. And again, we follow the same steps. Focus on that. We x plus 3, remember it's half of the 6 squared. Take away the 3 squared, my correction factor. I've then got negative 2 outside and plus 25 at the end. So now that I've got that, I can then multiply this out and start to simplify everything down. So I end up with negative 2 bracket x plus 3 squared. Then I've got negative 2 times minus 3 squared. So 3 squared is 9. So it's negative 2 times negative 9 plus 18 and then plus the 25 there at the end. Start to simplify the bits and put it back in this form. So the coefficient, the constant here, goes right back to the start. So 18 plus 25, that gives me 43, take away 2 bracket x plus 3 all squared. Once I've got it in that form there, I can simply read off my turning point. My turning point, when it's in this form, is still the same. It's still negative p comma q. So in this case, it's still negative p, so it's negative 3 comma q, which is 43. So I've got my turning point there. I then want my y-intercept, and again I set x equal to 0 for this. Plug in x equal to 0, and I get y equals 25, take away 12 times 0, take away 2 times 0 squared, so y equals 25 is my y-intercept. So mark that on, so there's my 25 there. Mark on my turning point, negative 3 comma 43, and then all I need to do now is fill in all the gaps. So I can fill in the graph coming off down here like this, and coming off down here like this. Yes, it's got roots, but that doesn't mean this doesn't help me to sketch it a lot easier. It lets me get the turning point and the y-intercept and sketch it on without having to use the quadratic formula to find the two roots and then average them out. Once we've sketched it, make sure we label it correctly. So y equals 25 minus 12x minus 2x squared. Label your y and label your x. Sketching them using this technique actually does help us. Helps us get some more important bits of information fairly quickly and easily, and it allows us to do more complex functions where factorising it isn't as easy as we thought. It would have to be the quadratic formula we'd use.